Hello, in this lecture we find out the length of line segment X. In the drawing we have a quarter circle, AOB is a quarter circle. Inside this quarter circle we have a semicircle, OB is a semicircle. In addition we know that line segment AO equals to 10 units in its length. And our mission is to find out the length of this line segment AM is equal to X. Okay, so first of all, because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees in size, it is a right angle. So this angle AOB equals to 90 degrees. In addition, side AO equals to side OB. They are both the radii of this quarter circle, therefore they are equal to each other. But it is given as an equation that AO equals to 10, therefore OB is also the radius of this quarter circle, will be also equal to 10 units. OB equals to 10 units. But OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. Okay, OB is also the diameter of the semicircle. We define the center of this semicircle here, this point as P. We know that the diameter OB of this semicircle equals to 10 units in its length. Therefore, the radius OP must be equal to 10 over 2, that is 5 units. Here, the radius PB of this semicircle also equals to 5 units in its length. We define the point of tendency of tangent AM with this semicircle as Q. And we join points Q and P together by a straight line. Point P is the center of the semicircle, point Q is a point on the semicircle itself, therefore PQ is the radius of this semicircle, therefore it is equal to 5 units in its length. Here we have rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. We have here tangent AB. This is tangent AB. That is tangent to this circle is point M. Point M is the point of tendency. And we have the radius OM that is drawn to point M. That is to say it is drawn to the point of tendency, that is point M. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule, rule number 1. We can actually implement rule number 1 in our drawing. Why? Because in our drawing we have the radius PQ of this semicircle that is drawn to point Q. That is to say it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP according to rule number 1, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. In the next step we focus at point A. The common example point A. We have here rule number 2. According to rule number 2, the lengths of two tangents from a common example point to a circle are equal. We have the common example point P. From the common example point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule number 2, they are equal to each other. That is to say, PA equals to PB. We can actually implement rule number 2 in our drawing. Why? Because in our drawing, if we focus on the common example point A, from the common example point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, they are equal to each other. That is to say, AO equals to AQ. But AO equals to 10, therefore AQ must be also equal to 10 because they are equal to each other. AQ also equals to 10 units in its length. In the next step, we will extend line segment AM and line segment OB by a straight line until they touch each other. So this is their touching point. We define their touching point as N. By doing this construction, we actually created here the big right triangle, triangle AON. We'll focus on the big right triangle, triangle AON. We define this angle A and O as theta. So in the right triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, we'll continue. We will focus on the right triangle, triangle QPN. On this right triangle, triangle QPN, according to the same logic, we have this angle that is equal to theta, this angle equals to 90 degrees, therefore this is the missing angle that must be equal to 90 degrees minus theta. Okay. In the next step, we will prove that the right big triangle, triangle AON, is similar to the right green triangle, triangle QPN. Why those two right triangles are similar to each other? First of all, I will write it down. We will prove that the right big triangle, triangle AON, is similar to the right green triangle, triangle QPN. So why the big right triangle AON is similar to the green triangle, triangle QPN? First of all, those two angles are both equal to 90 degrees, therefore they're equal to each other. So this is angle AON in the big right triangle AON. And it is equal to this angle, the actual angle PQN in the green triangle. Repeat again. Angle AON in the big right triangle AON equals to angle PQN in the green triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, we have this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. So if we relate to this angle, angle theta, as it belongs to the big right triangle AON, it will be angle NAO. And it is equal to itself. So if we relate to angle theta as it belongs to the green triangle PQN, it will be defined as angle PNQ. Again, if we relate to angle theta as it belongs to the right big triangle AON, it will be angle ANO. Repeat again. This equation means that angle theta equals to itself. We just call to angle theta two different names. Angle theta equals to itself as a common angle that belongs to both triangles. Okay, and finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle NAO, the big triangle ANO, and it is equal to this angle. This is actually angle QPN, the green triangle. Repeat again, angle NAO in the big right triangle ANO equals to angle QPN in the green triangle. QPN, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually, in conclusion, found out that all the three angles in the big right triangle AON are correspondingly equal to all the three angles in the green right triangle QPN. Therefore, we actually proved that the right big triangle AON is similar to the green right triangle QPN according to angle similarity rule. So I write it down. We actually proved that the right big triangle AON is similar. This is the sign of similar to the right green small triangle QPN. They are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that AO in the big right triangle, side AO in the big right triangle AON over side QP in the green triangle QPN equals to side AN in the big right triangle ANO over side PN in the green triangle PQN. And again, we derive that AO over QP equals to AN over PN, and it is also equals to side ON in the big right triangle AON over side QN in the green triangle QPN. Repeat again, we derive that AO over QP equals to AN over PN equals to ON over QN. AO equals to 10 units in itself according to what is given as the question, over QP. QP equals to 5 units in its length. What is the length of AN? From the drawing it is very easy to see that AN in total equals to AQ plus QN. AQ is 10 and QN is the missing side, so in total AN equals to 10 plus QN. Here AN equals to 10 plus QN over PN. What is the length of PN? From the drawing it is very easy to see that PN in total equals to PB plus BN. That is to say PN equals to PB, that is 5 plus BN. So in total PN equals to 5 plus BN. PN equals to 5 plus BN. And it is also equals to ON over QN. ON, what is the length of ON? From the drawing it is very easy to see that ON in total equals to OP, that is 5, plus PB, that is 5, so this is 5 plus 5, that is 10, plus BN. So in total ON equals to 10 plus BN. Here ON equals to 10 plus BN. divided by Qn. Qn is the missing side, so we will leave it as it is. 10 over 5 is 2, so 2 equals to 10 plus Qn over 5 plus Bn, and it is also equals to 10 plus Bn over Qn. So those two sides are equal to each other, therefore we create equation number 1 from those two sides that are equal to each other. According to equation number 1, we get that 2 equals to 10 plus Qn over 5 plus Bn. Repeat again. According to equation number 1, 2 equals to 10 plus Qn over 5 plus Bn. Those two sides are also equal to each other, therefore we create equation number 2 from those two sides that are equal to each other. According to equation number 2, we will get that 2 equals to 10 plus Bn over Qn. Repeat again. According to equation number 2, we will get that 2 equals to 10 plus Bn over Qn. So we have here two equations. In the next step, we multiply this equation number 1 by 5 plus Bn, and we get that according to this equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. Here we open the brackets of this side of equation number 1, and we get that according to equation number 1, 2 times 5 is 10, that is equals to 2 times Bn is 2Bn, so 10 plus 2Bn equals to 10 plus Qn. So here, in this equation number 1, we have 10 on both sides of the equation, so 10 we get cancelled. After we cancel 10, we left only with Qn, that is equals to 2 times Bn. Repeat again, according to equation number 1, we found out that Qn equals to 2 times Bn. This is according to equation number 1, while according to equation number 2, we found out that 2 equals to 10 plus Bn over Qn. Here we multiply this equation number 2 by Qn, and we get that this, according to this equation number 2, 2 times Qn equals to 10 plus Bn. According to equation number 2, 2 times Qn equals to 10 plus Bn. Well, according to equation number 1, Qn equals to 2 times Bn. So actually we can substitute Qn in this equation number 2 by 2 times Bn in equation number 1. We'll do it now, and we get that according to equation number 2, 2 times Qn, and Qn is 2 times Bn. So Qn is 2 times Bn. And according to equation number 2, it is equals to 10 plus Bn. Two times 2Bn is 4Bn. So according to equation number 2, we found out that 4 times Bn equals to 10 plus Bn. Here we subtract Bn from this equation number 2, And we get that according to equation number 2, 4 times Bn minus Bn is 3 times Bn. So 3 times Bn equals to 10 according to this equation, equation number 2. We divide this equation number 2 by 3, and finally we get that according to equation number 2, Bn equals to 10 over 3 units in its length. So here, line segment Bn, this is line segment Bn, that is equal to 10 over 3 units in its length. So I write it down. This line segment Bn equals to 10 over 3 units in its length. According to equation number 1, we have already found out that here Qn equals to 2 times Bn. So according to equation number 1, Qn equals to 2 times Bn, and Bn is 10 over 3, so it's 2 times 10 over 3, and 2 times 10 over 3 is 20 over 3. So we're going to find out that Qn equals to 20 over 3 units in its length. So I can write down here that this line segment Qn equals to 20 over 3 units in its length. In the next step, we'll complete this quarter circle to a circle. So we actually completed the quarter circle to a circle, and we'll extend line segment BO by a straight line until it touches the circle. This is the touching point of line segment, the extended line segment BO with this circle. We'll define the touching point of the extended side BO with this circle as C. Point O is the center of this circle, point C is the point of the circle itself, therefore OC is the radius of this circle. The radius of the circle and the radius of the quarter circle are the same because we just extended the quarter circle to a circle, therefore they absolutely have the same radius. And we know that the radius of the quarter circle is 10, therefore the radius of the circle CO must be also equal to 10 units in its length. In the next step I will present to you rule number 14, and we will implement rule number 14 in our drawing. According to rule number 14, rule number 14 is true in any circle. So in any circle, if we draw two chords A, B and C, D inside the circle from the common external point P, then the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. So in the drawing we have a circle and the common extent point P. From the common extent point P we draw two chords inside this circle, chord AB and chord CD. So here in this drawing the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. You can actually implement 1 over 14 in our drawing. Why? Because in our drawing we have the common extent point N. From the common extent point N we have two chords that are drawn from the common extent point N inside this circle. We have the first chord is called MA, and the second chord that is drawn from point N is called BC. So all the requirements of 1 over 14 are met, therefore we can implement in this drawing 1 over 14. According to 1 over 14, you get that NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. So I write it down. If you focus on the common extent point N, according to rule number 14, NB times NC will be equal to NM times NA. Repeat again. If you focus on the common extent point N, in our drawing, according to rule number 14, we get that NB times NC equals to NM times NA. So first of all, we have to find out the length of line segment NM. What is the length of line segment NM? From the drawing it is very easy to see that NM equals to Qn minus Qm. Again, Nm equals to Qn minus Qm. Repeat again. From the drawing it is very easy to see that Nm equals to Qn minus Qm. So Nm equals to Qn. Qn is 20 over 3. Here, Qn is 20 over 3 minus Qn. So in total, we actually found out that Nm equals to 20 over 3 minus Qm. Now we return to rule number 14. According to rule number 14, we already found out that NB times NC equals to NM times NA. So we have here NB. NB is 10 over 3 times NC. What is the length of NC? NC and Cn are the same, so Cn in total equals to CO, that is 10, plus OP, that is 5, plus PB, that is 5, plus BN, that is 10 over 3. So in total, Cn equals to 10 plus 5 plus 5, that is 20, plus 10 over 3. Again, repeat again, Cn in total equals to 20 plus 10 over 3. So here, and C in total equals to 20 plus 10 over 3, and it is equal to Nm. We just write down found out that Nm equals to 20 over 3 minus Qm times Na. What is the length of line segment NA? NA and AN are the same, so NA in total, NA is AN, AN in total equals to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN, that is 20 over 3. So in total, AN equals to 10 plus 20 over 3. Here, AN equals to 10 plus 20 over 3. So actually found out that 10 over 3 times 20 plus 10 over 3. Here we multiply 20 by 3 and then we divide it by 3 in order to overcome factor with 10 over 3. 20 times 3 is 60 and 60 plus 10 is 70. So in total the numerator of this expression we have 70 divided by 3. This equals to 20 over 3 minus Qn. We multiply minus Qn by 3 and then we divide it by 3 in order to overcome factor with 20 over 3. So in the numerator in total we have 20 minus Qm times 3 is minus 3 Qm. So in total in the numerator of this expression we have 20 minus 3 Qm divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to overcome factor with 20 over 3. So 10 times 3 is 30 and 30 plus 20 is 50. So in total in the numerator of this expression we have 50 divided by 3. So here in this equation we have 3 times 3 on both sides of the denominator of this expression. Therefore we multiply this expression by 9 in order to eliminate the denominator of 9. Okay. So after we eliminated the denominator of this side of the equation, we left only with 10 times 70. Is equal in the other side of the equation after we eliminated 9 from the denominator, we left only with 20 minus 3 Qm times 50. Repeat again. We actually found out that 10 times 70 equals to 20 minus 3 Qm times 50. Here we divide this equation by 10 and you get that 10 over 10 is 1, so in this side of the equation we left only with 70. That is equals to 20 minus 3 Qm times 50, and 50 over 10 is 5. So in conclusion, we found out that 70 equals to 20 minus 3 Qm times 5. Here we'll open the brackets on this side of the equation. We will get that 70 equals to 5 times 20 is 100, and minus 3 Qm times 5 is minus 15 Qm. So in conclusion, we found out that 70 equals to 100 minus 15 Qm. Here we subtract 70 from this equation and we get that 70 minus 70 is 0. That is equals to 100 minus 70 is 30. That is equals 30 minus 15 Qm. So in conclusion, we found out that 0 equals to 30 minus 15 Qm. Here we will add 15 Qm to this equation and we get that 15 Qm equals to 30. Here we divide this equation by 15 and finally we get that Qm equals to 30 over 15 is 2. So Qm equals to 2 units in its length. So here this line segment Qm equals to 2 units in its length. So here you can write down that QM equals to 2 units in its length. Our mission is to find out the length of this line segment AM that is equal to x according to what is given us the question. Repeat again, we have to find out the length of line segment AM that is equal to x. But from the drawings it's very easy to see that AM equals to AQ plus QM. Again, AM equals to AQ plus QM. AM equals to AQ plus QM. So AM equals to AQ. AQ is 10 plus QM. QM is 2. So in total, AM equals to 10 plus 2, that is 12. So I actually found out that X, that is equals to AM, is equals to 12 units in its length. And that is the answer to our question. The length of line segment X that is equal to the length of line segment AM that is equal to X, it is equals to 12 units. So in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment AM that is equal to x according to what is given us in the question. In the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle, we have this semicircle. In addition, we know that the length of this line segment AO is equal to 10 units. Again, our mission is to find out the length of this line segment AM that is equal to 10. The length of line segment AM that's equal to x according to what is given us in the question. AM equals to x. We have to find out the length of line segment AM that's equal to x. Okay. So we know that AOB is a quarter circle, therefore this angle AOB must be equal to 90 degrees, and AO and OB, both those two line segments, must be the radii of this quarter circle, and therefore they are equal to each other. But we know that AO equals to 10, therefore OB must be also equal to 10 units in its length. It is the radius of this quarter circle. But OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. Again, OB is the diameter of this semicircle, and it is equal to 10 units. We define the center of this semicircle as P, therefore the radius PB must be equal to the diameter over 2, that is to say, it must be equal to 10 over 2, that is 5. The radius PO must be also equal to 5 units in its length. Then we define the point of tendency of tangent AM with this semicircle as Q. And we join points P and Q together by a straight line. Point P is the center of the semicircle, point Q is the point of the semicircle itself. This is exactly the definition of a radius. So PQ is the radius of this semicircle, and therefore it is equal to 5 units. Then we have rule number 1 here. We have the radius PQ that is drawn to the point of tendency. That is to say, it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. Whenever we have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. That is to say, this angle equals 90 degrees and this angle equals 90 degrees according to rule number 1. Then we focus on the common external point A. From the common external point A, we have two tangents to this semicircle. We have tangent AO and tangent AQ. And according to rule number 2, they are equal to each other. That is to say, AO equals to AQ, but AO equals to 10, therefore AQ must be also equal to 10 units in its length. Okay, then we extended line segment AM, this line segment AM, and line segment BO by straight line until they touch each other. This is their touching point. We define their touching point as N. By doing this construction, we created the right big triangle, triangle AON. This is the right big triangle, triangle AON. We define this angle as theta, and we continue to focus on the right big triangle AON. In the right big triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Then we focused on the green right triangle QPN. According to the same logic, in the right big triangle the right green triangle QPN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Then we prove that the right big triangle, triangle PQN, is similar to the green triangle Q. Again, the right big triangle AON, this is the right big triangle AON, is similar to the right green triangle QPN. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles, and finally those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we proved that all the three angles in the right triangle AON are correspondingly equal to all the three angles of the small green triangle QPN. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that AO over QP equals to AN over PN equals to ON over QN. AO is 10, QP is 5, and it is equal to AN. What is the length of AN? AN equals to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN. So in total, AO equals to 10, AN equals to 10 plus QN. Here, AN equals to 10 plus QN over PN. What is the length of PN? From the drawing, it is very easy to say that PN in total equals to PB plus BN. That is to say, PN equals to PB, that is 5, plus BN. So in total, PN equals to 5 plus BN. Here, PN equals in total to 5 plus BN. And it is equals to ON. What is the length of ON? From the drawing, it is very easy to see that ON equals to OP plus PB plus BN. So ON in total equals to OP, that is 5, plus PB, that is 5. 5 plus 5 is 10, plus BN. So in total, ON equals to 10 plus BN. Repeat again. ON equals to 10 plus BN over QN. QN is the missing side, so we leave it as it is. Here, 10 over 5 is 2, so 2 equals to 10 plus QN over 5 plus BN, and it is equals to 10 plus BN over QN. So here, those two sides are equal to each other, therefore we created the equation number 1 from those two sides that are equal to each other. So according to equation number 1, 2 equals to 10 plus QN over 5 plus BN. This is according to equation number 1. Again, according to equation number 1, 2 equals to 10 plus QN over 5 plus BN. We have those two sides that are also equal to each other, therefore we created the equation number 2 from those two sides that are equal to each other. According to equation number 2, 2 equals to 10 plus Bn over Qn. Repeat again. According to equation number 2, 2 equals to 10 plus Bn over Qn. So we have here two equations. Here we multiply this equation number 1 by 5 plus Bn, and found out that according to this equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. Again, according to equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. Here we open the brackets on this side of the equation number 1 and found out that 2 times 5 is 10 plus 2Bn equals to 10 plus Qn. Here we have 10 on both sides of the equation, so 10 will get cancelled. And we have to leave with Qn that is equals to 2 times Bn. Here, according to equation number 1, we found out that Qn equals to 2 times Bn. This is according to equation number 1. Here, we multiply this equation number 2 by Qn, and we found out that 2 times Qn equals to 10 plus Bn. Again, 2 times Qn equals to 10 plus Bn. This is according to equation number 2. So here, we can substitute Qn in this equation number 2 by the value of Qn that we found in equation number 1. According to equation number 1, Qn equals to 2 times Bn. So we can substitute Qn in this equation number 2 by 2 times Bn. We did it and found out that 2 times Qn, so Qn is 2 times Bn, Qn is 2 times Bn, so it is 2 times 2Bn, that is equals to 10 plus Bn. That is equal to 10 plus Bn. Here 2 times 2Bn is 4Bn, so 4Bn equals to 10 plus Bn. Here we subtracted Bn from this equation number 2, and found out that 4Bn minus Bn is 3Bn, so 3Bn equals to 10. 3Bn equals to 10 according to equation number 2. We divided this equation number 2 by 3, and finally found out that Bn equals to 10 over 3 units in its length. Here, the line segment Bn, this line segment Bn equals to 10 over 3 units in its length. This is according to equation number 2. Well, according to equation number 1, we have already found out that Qn equals to 2 times Bn. So Qn equals to 2 times Bn, and Bn is 10 over 3, so it is 2 times 10 over 3. 2 times 10 over 3 is 20 over 3. So we found out that Qn equals to 20 over 3 units in its length. Here Qn, this line segment Qn equals to 20 over 3 units in its length. Okay, then we completed this quarter circle to a circle, and we extended line segment BO by straight line until it touches the circle. We define the touching point of the extended line segment BO with this circle as C. So point O is the center of the circle, point C is the point of the circle itself, therefore OC is the radius of this circle. The radius of this circle is equal to the radius of the quarter circle. Why? Because we just extended the quarter circle to a circle, therefore they absolutely have the same radii. But we know that the radius of the quarter circle equals to 10, therefore the radius OC of the semicircle must be also equal to 10 units because they are equal to each other. Then I presented to you rule number 14 and we implemented rule number 14 in our drawing. According to rule number 14 is true in any circle. So in any circle, if you draw two chords A, B and C, D inside the circle from the common standpoint point P, then the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. So in the drawing we have this circle and we have the common standpoint point P. From the common standpoint point P, we drew two chords inside this circle, chord AB and chord CD. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can implement rule number 14 in our drawing. Why? Because in our drawing, we have the common standpoint point N. From the common standpoint point N, we have two chords inside this circle, chord AM and chord CB. Therefore, all the requirements of rule number 14 are met, and therefore we can implement rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. Okay, again, according to rule number 14, if we focus on the common standpoint point N, we get that NB times NC equals to NM times NA. So, first of all, we have to find out the length of line segment NM. From the drawing, it is very easy to see that the length of line segment NM equals to Qn minus Qm. Again, Qn minus Qm equals to NM. It again, NM equals to Qn minus Qm. Qn is 20 over 3, so in total Mn equals to 20 over 3 minus Qm. Here, this line segment Mn in total equals to 20 over 3 minus Qm. Now we return to rule number 14. According to rule number 14, we have already found out that NB times NC equals to MN times AN. So it is NB. NB is 10 over 3. NB is 10 over 3 times NC. NC is Cn. NC is Cn, and Cn in total equals to CO plus OB plus Bn. So in total, Cn equals to CO, that is 10, plus OP plus PB plus Bn. So Cn in total equals to CO, that is 10, plus OP, that is 5, plus PB, that is 5. So 10 plus 5 is 20, plus Bn, that is 10 over 3. So in total, Cn equals to 20 plus 10 over 3. Here, Cn in total equals to 20 plus 10 over 3, and it is also equals to Na. What is the length of Na? From the domain itself, Na is An, and An in total equals to Aq plus Qn. That is to say, An equals to Aq, that is 10, plus Qn, that is 20 over 3. So in total, An equals to 10 plus 20 over 3. Here, An equals to 10 plus 20 over 3. So here we have 10 over 3 times 20 plus 10 over 3. We multiply 20 by 3 and then we divide it by 3 in order to have a common factor of 10 over 3. So 20 times 3 is 60, and 60 plus 10 is 70. So in total, in the numerator we have 70 divided by 3, and it is equals to 20 over 3 minus Qm. Here we multiply minus Qm by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. So in total, in the numerator we will have 20, and minus Qm times 3 is minus 3 Qm. So in total, in the numerator we have 20 minus 3 Qm divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. And finally found out that in the numerator we have 20 times 3, that is 30, plus 20. 30 plus 20 is 50. So in total, the numerator of this expression we have 50 divided by 3. So here, on both sides of the equation, we have 9 in the numerator. 3 times 3 is 9. Therefore, multiply this equation by 9 in order to eliminate the denominator 9. And we left only, after we multiplied by 9, we left only, in this side of the equation, we left only with 10 times 70. On the other side of the equation, we left only with 20 minus 3 Qm times 50. Here we divided this equation by 10 and found out that 10 over 10 is 70, and 10 over 10 is 1, so we left only with 70. And it is equals to 20 minus 3 Qm times 50, so 50 over 10 is 5. So in total we found out that 70 equals to 20 minus 3 Qm times 5. Here we open the brackets on this side of the equation and finally found out that 70 equals to 20 times 5 is 100, and minus 3 Qm times 5 is minus 15 Qm. So in total we found out that 70 equals to 100 minus 15 Qm. Here we subtracted 70 from this equation and finally found out that 70 minus 70 is 0, and 100 minus 70 is 30, minus 15 Qm. So in conclusion we found out that 0 equals to 15 minus 0 equals to 30 minus 15 Qm. Here we added 15 Qm to this equation and finally found out that 15 Qm equals to 30. Here we divided this equation by 15 and finally found out that Qm equals to 15 over 30, that is 2. So Qm equals to 2 units in length. This line segment Qm equals to 2 units in length. Our mission is to find out the length of this line segment AM that is equal to x according to what is given us in the question. So here we have to find out the length of line segment AM that is equal to x. From the domain it is very easy to see that AM in total equals to AQ plus QM. Again, AM equals to AQ plus QM. So we can write here that AM equals to AQ plus QM. AQ is 10 and QM is 2. Again, AQ is 10 and QM is 2. So in total AM equals to 10 plus 2, that is 12. So we actually found out that the length of line segment AM that is equal to x according to what is given us in the question is equals to 12 units in its length. I'll repeat again, the length of line segment AM that is equal to x is equals to 12 units. Okay, thank you very much.